sendiri. Climate change footprint in our oceans. Yeah, you just mentioned that you can from the corals. It can be to measure the what happened in the past. Gitu. Also ocean sediments, ice core.
Okay, let's continue on the ocean acidification. So other than ocean acidification, what else are happening to our oceans? I think you have the floor. So ocean acidification, so the answers are four. One is ocean acidification. What are the other three?
Global warming.
Yeah.
And then sea level rise.
Yes.
And then less oxygens and more CO2.
You're right.
Yay! Congratulations! And one more quiz for our audience. Yes.
So what are the three? We have the mic. Oh.
The eccentricity, obliquity, and precession.
Exactly.
Yay! To our winners, please join us here for prize session. Our first winner, picture please. And our second winner, big applause for them. Yay! Now we will continue to Q&A session. So be ready with your question. So Dr. Intan, please have a seat. And now I will open the Q&A session. Our online viewers also have the opportunity to ask questions to Dr. Intan via comment box of our streaming video. And audience, if you have a question, please raise your hand, mention your name and institution, and please stand up. Okay, the lady with the blue hijab.
Good morning, my name is Lolita from Ministry of Marine Affairs and Fisheries, Research Center for Fisheries. I don't know if my question is really your presentation, but I want to know your opinion. Indonesia priorities to achieve our previous president goal to reduce greenhouse gas from this country about 41% in 2020, especially related to acidifying of the ocean. What the main priorities of Indonesia to be taken care of? Okay, maybe that's my question. Thank you.
So yeah. So that's actually really nice. So in terms of climate change, there are actually two things that we look at. One is adaptations. Adaptation is how we would adapt to the changes. And the other one is the mitigation. Mitigations is how we would reduce the amount of CO2. So Indonesia has this goal to reduce CO2. And I think we do have many avenues. I think so far we've put so much attention on land. So, for example, how we reduce deforestation. So, forest is the lung of our planet. We need it to take the CO2. How we should not burn the peatland. Because peatland has a lot of carbon. So, if you burn rawa-rawa, then you really put a lot of carbon into the atmosphere. But as an archipelago country, I would say that we still lacking in terms of our understanding of how much our oceans will play into role, how much we can absorb. So actually, at RCOEP, it's research not conducted by me, but my colleague, for example, start looking at the mitigation potential of an area. So let's say we have pulau something, right? This pulau something is actually putting atmosphere into the oceans or absorber or oceans. And actually we can look at the mangroves because mangroves also locked in carbon. And yesterday we have Mas Udi talking about seagrass. Seagrass actually also something that really needs to look at because it has many good things. sometimes I feel bad to seagrass because people think about coral reefs so beautiful and then they forget about seagrass. They're just greens, but they're very important. And seagrass is interesting because to some extent, seagrass will benefit from climate change because they absorb CO2, but to some extent, when you have ocean acidifications, it will be harmed. So I think what Indonesia needs to understand, given that most of our areas are oceans, how much can we absorb CO2 with our ocean part, not just the land part? I think KLHK, as the ministry behind this, have started to look at and involve the ocean part, and I think that's the right direction. In terms of ocean acidification, it's actually we don't have data on ocean acidification in Indonesia. That's just the hard truth. We talk about this a lot. We talk about how it will be dangerous to our coral reef, given that we are the center of coral reef. But actually, the UN has the IOC, the subcommissions that deals with the oceans, and in our regions there is the IOC WESPAC, the IOC of the Western Pacific. Now, what this body does, one of the programs is monitoring the ocean acidifications. So every country have to do something in terms of monitoring and report. And unfortunately, we really slow on this. At LIPI, we wanted to be serious on this. This is a serious issue. How you assess anything without data, right? You just say it's dangerous, but there is no data. So at RCO LIPI, we have actually many ways that we look at ocean acidifications. So we start monitoring ocean acidification using the standard operating procedure from the UN. And that site's in Lombok. That's the only place, to my knowledge, the first one in Indonesia, that applies all the SOPs. Monthly monitoring, coral calcification is there, calcification unit is there, as well as ARMS. ARMS is like little apartments in the oceans. But I think with that, I've seen university lecturers, also ministries. LIPI cannot do this alone. So if you can add more station sites to this effort, that would be great. And at LIPI, like I said, we didn't measure in pH in the past, and the time has passed. We just don't have this data. So as I'm a paleoclimatologist, what I do is actually I use corals to reconstruct pH of our oceans. And I can tell you that it's not as simple as we thought. Our oceans are so complex, we have to respect this. In open ocean settings, we know like in Indian Ocean, Pacific, they have monitoring data, and the pH is going down like really nicely. Like this is ocean acidification at play, right? But in Indonesia, we have monsoon, our oceans are, it's sort of semi-enclosed. We're not really open ocean, right? We have so many island surroundings. So what I see in my data is that even natural cycle of pH in Indonesia is very high. So we need to understand this before we can say anything. How much is ocean acidifications really have imprints in Indonesia? So I think data is the key here. Thank you.
Okay, thank you. What an excellent answer. So until now, we still don't have an online question. So I will open another question from our audience. Another question? Okay, sir.
Yeah, thank you very much. My name is Roy Andreas from Jenderal Sudirman University, Center of Bioscience Maritime. Actually, I'm very agree with you that if I just remember that maybe 2-3 years ago, my supervisor told me that if you want to understand about the Earth, so the most important is you have to understand about the ocean. Because the ocean is cover our Earth maybe more than 70%, something like that. Okay. Actually, it's very interesting and wonderful presentation for me, because in this time we can see that Indonesia have 70% of area is ocean, covered by ocean. So that means if we want to understand about our country, Indonesia, especially Indonesia, we have to learn and understand also about our ocean. First, my question is, actually, I didn't see the number from your presentation. Maybe can you told us maybe average or something like that? Because between ocean and atmosphere, they always have something exchange, gases exchange between atmosphere and surface water. Can you tell maybe average or number of average, something like that? How about the rate of gas exchange between the atmosphere with the surface water? The normal, I mean the normal number, something else. And what's the happen now? How about the present? Now there is still normal or not, something like that. Maybe if you have kind of data about this.
Can I just exchange of what? Like
Gas,
CO2?
yes, CO2
Okay.
or maybe O2, because you told us that now so many oxygen is something go to the atmosphere from the ocean, right? And how about the CO2, something like that? Maybe that's why. That's maybe one personality. Thank you.
So yeah, what is the rate of exchange of CO2? And it goes both ways, you're right. So it varies between places. There is no one number. Even in Indonesia, for example. So I said this study by my colleague at ITB. So he was using data from Barunajaya cruises from many times. So he was measuring PCO2. So how much CO2 is going? Is CO2 going in from the ocean to the atmosphere or atmosphere to the ocean? So the question was: is Indonesia contributing to global warming, or are we actually absorbing, right, with our oceans? So he was actually showing that it's very different even in our country. So the western part of Indonesia, we have shallow oceans, 200 meters, and also have big cities, a lot of pollution, I'm sure. As it turns out, many of the western part is actually emitter. So they're actually more, so CO2 actually flowing from the oceans into the atmosphere. But the case is different in the east. The east, we have deeper oceans and more pristine, and they're actually absorber. As in terms of the numbers, I don't remember what he wrote in the paper, but I could send you the paper. So my point is, even in Indonesia, it's different. So of course, on a global scale, though, we have logically, as we keep increasing CO2 in the atmosphere, so on a global scale, the ocean right now is the absorber, because with the global cycle figures, for example. But again, the small scale understanding, like Indonesia, for example, is very important. And I think information like this will be important to like KLHK when what's the number? Is Indonesia emitter or absorber? And this information is actually important for them for the negotiations of climate. So we know neraca carbon or budget, carbon budget. What's Indonesian role on this? What Indonesia should do. So right now, yeah, we have more data on land than from the oceans.
Okay, now we have an online question from Divo Aryo. Hi, Divo Aryo. The question is that possible? What happened in the movie The Day After Tomorrow, 2004, happened to us, the moment when we lose climate balance cause overcome of fresh water due to the melting ice from our pole region.
Yes, I saw that movie when I was in grad school. That movie was interesting because there's actually really good basic climate science on this. So the sexy part of it is, some people think our ocean, it's just water everywhere, same thing. But our ocean have a conveyor belt. So it's like, water from the Pacific goes into the Indian Oceans actually, then it goes to the Atlantic, and then they get colder, and then they sunk into the bottom of the Northern Atlantic. So it's like a conveyor belt that connects to the ocean. So there's no Pacific, Indian, Atlantic Ocean. It's one big oceans that are connected. So what movie highlight was, in the past it happened that so the conveyor part in the Atlantic can stop or slow down when you have a lot of fresh water in that area. And it did happen. We know from the ice record, the sediment record, that happens. So that movie took that idea, but it did exaggerate it. Like if that happens, and we see that it might happen, the slowing down of the this conveyor belt, but it wouldn't happen like that. Was like within days, and he lost his kid and tried to find his kid and something like that. It could happen, but it's not as fast as that. Yeah.
This is a very quick question for me because of my curiosity. In the slide of Nature Archive, is that a picture of you?
Yeah.
Oh, she also a good diver. And we have another question from audience. Okay, the lady with the black shirt.
Okay, thank you so much. My name is Sarah from Econusa. Thank you for your inspirational presentation. So let's move forward. Okay. So how we prevent coral bleaching and ocean acidification on the next 5 years? And if LIPI has data about this problem, how LIPI tell this warning, especially to coastal local community? Thank you.
Thank you. Excellent questions. Yes. So coral bleaching and ocean acidifications, they have different pace, right? Coral bleaching actually happens when you have suddenly like very hot temperature, and it's too hot for corals to live, and they escape from the batu karang, and the corals bleach. So that happens very quickly, and usually things like El Nino will trigger coral bleaching. For example, in Kepulauan Seribu, if you have El Nino, almost coral bleaching is there. For sure. Whereas ocean acidification is a very slow process. So at this point we monitor it, but we don't have alert. Now, so in terms of alert to the coastal community, that would be in terms of coral bleachings. Actually, for example, NOAA, the U.S. National Oceanographic Administrations, they have actually a nice coral bleaching alerts all over the globe. So what they do, because we have satellite data, we know what the sea surface temperature. So when we start seeing, like, let's say in Kepulauan Seribu there is a hotspot of temperature, then we could alert the immediate response or immediate dangers of coral bleaching in that area. So in 2016, around Lombok there was like massive coral bleaching, but if you look at the sea surface temperature from the satellite, yeah, indeed, you have this red blob around the region, but only in that area. It's less in the Sumatra and so on. So yes, I think what Indonesia needs to do is to also monitor this coral bleaching alert. Especially if you work in a particular type of area, let's say you work in Wakatobi, you want to know when it will happen, then do check out their website, check out the sea surface temperature from the data from the satellite, and that will be a quick way to tell coral bleaching. For ocean acidification, because it's a slow process, and many people don't realize it, I'm also still trying to communicate it. So what in terms of alert, basically, for example, our work in Lombok, the reason I chose Lombok because they have Kerang Mutiara, right? So calcification is not just an issue of ecology, it's an issue of economy. So let's say if their water is becoming more acidic, not only the corals are in danger, but their Kerang Mutiara economy, the pearl industry, will be affected. But I need data for that, so that's why I go to Lombok. I also look at all these parameters, and I want to see what's the status. Maybe it's no problem. Maybe pollution is a bigger issue than ocean acidification, but that's the data. The local government needs to know whether their economy will be affected or not. I did talk to some of the pearl industry nelayan Kerang Mutiara. I talk about, okay, do you see any issues? They did tell me about, so in order to breed, they need to breed Kerang Mutiara, right, the pearl, and then they need to start trigger the Mutiara. So what they did was they have to make to breed the mutiara to a certain size, let's say 12 centimeters, then they trigger the mutiara. So mutiara is not a natural process, then you have to trigger it. But only when they reach a certain age, a certain size. But they say in the last few years, it's getting harder for them to get that size. So instead of 12 centimeters, maybe when they already reach 8 and they're not growing as fast as they want, they start triggering. But I did ask them, so do you know what's caused this? Have you heard about ocean acidifications? But of course, then I realized there's also an issue of pollutions there. So I think something like that just to connect what happens in the field, and this could be a sign of ocean acidification or not, is something that LIPI as a research institute needs to understand. Yeah, it's still ongoing though. I don't have data yet from Lombok. Thank you.
Okay, thank you, Dr. Intan, for your explanation. Now we have an online question from Lutfiah Aziza. It's really interested to collect the historical data from the coral, but what type of coral that could give us such complete information? And if the coral are already bleached, can it still give the info?
Alright, so the type of the corals that you can use different corals, but for the sake of getting as long as possible, so there's branching corals, right? There's a massive one. The branching corals is difficult because they're very short-lived. So even if you sample that, you only get 10 years, which is not much in terms of climate. So what I look is the massive one, like Porites. So Porites is like the big kind of mound, and they can live to 200 years, 300 years. So they're perfect. I use Porites because it's easy to find. It's one of them, you find Porites everywhere in the Indo-Pacific, so it's easier to find. And also it's easier to work in the lab. But other types like Diploria, Diploastria, you can use them. Some are harder to drill. I think Diploastria, it takes more energy to drill. You can use them. It's more difficult to interpret in the lab. I remember, I went to a field work in Kuwait once. I don't know what to expect when I went to Kuwait in the Middle East. I had never been there. So I wanted to find big varieties, a nice shaped one. I couldn't find big varieties. So at that point, I have to be flexible. So I saw this mound of coral, because I'm not a coral expert, so I'm like, I don't know what this coral is, but it looks really nice, and I think if we drill, we can get nice information. So I just drilled that coral because it's nice shape, and then later in the lab, I asked the coral scientist, okay, what is this coral? So yeah, you can be flexible. It's hard to get bigger and nicer corals these days, actually. If they bleach, they give an info. So if they bleach, sometimes they bleach kind of like dying, but sometimes they're really dead. You see that in the signals. You see that in the calcifications. You see that in the density. So the physical parameters, you see it in the geochemical. Actually, one of my study sites in the Central Pacific, when El Nino hits 97, it was just, you can see the geochemical data just drops. So actually for coral scientists, this could be something interesting. You can actually use geochemistry to see changes in bleaching. You can study with isotopes to look at, now I'm going to go technical, autotrophy versus heterotrophy, stuff like that. Yes.
Okay, another question? Okay, lady with the black hijab.
Assalamualaikum warahmatullahi wabarakatuh.
Salam.
My name is Putri. I'm from Mid-Ocean Consultant. Okay, actually I have a lot of questions, but some people already intersection with my questions. But basically, I want to know. I know that data is really important in research, but how quick your research result affect the government policies? How large of people, how wide people can access the results of the research, like industries and students, because as you say that we cannot do anything without the data. So yes, that's enough for me. Assalamualaikum warahmatullahi wabarakatuh.
quick can scientists provide this data? For my field, personally, it's a very data-driven. Usually, it will take 2 years from the sampling to the publication, 2 to even 3 years until the scientific publication is out. Some other works, maybe the modeling community is faster in terms of the rate of publishing. So realizing this, like you say, so you have to be creative in terms of communicating. You don't have to wait, I don't have to wait 3 years. I don't want to wait 3 years until I can communicate. So for example, with the projects, I always try to make videos. So I want, even sometimes when we have results, non-scientists may not understand it. They don't want the technical part, right? They just want the surface part, and I think that's important. So I think, so scientists, we have to be creative in terms of scientific disseminations. So such as the issue. For example, starting with the issue itself. If you make videos of the issue of what you do and what people should start being aware, you can do that in your first year of projects, right? So I try to do that, and I think thank you like for events like this. I can also communicate even the data is ongoing, and then you have the data. Scientific publication is a difficult process. You get rejected and whatnot, you know, right? But it's a good thing because you really sharpen your analysis. But it takes, for example, 3 years. Then what? Then you communicate to local government, the national government, if they hear. Now, for the climate in particular, there's also the IPCC. The IPCC is basically a bunch of scientists from all around the world get together. One section talks about the status of the climate change, one talks about the adaptations, one talks about mitigations, so how we reduce CO2 in the atmosphere. Now, I can even tell you the process of IPCC. So IPCC just start, so they make assessment report periodically. The last one was 2014. That was the 5th assessment report. So now they're making the 6th one. Now the 6th one, this year, we start putting together the people. So who are the peoples? And it won't be released until 2011 because within the next 3 years, we have to pull together information from these scientific publications about climate change status, and we have to select, we have to make sure this is really data that we can trust, because otherwise then the IPCC will be hit then, you know, by the climate skeptics. And you can imagine, even compiling takes 3 years. But once it's there, like you say in my presentations, I kept mentioning about IPCC report AR5 statements. So one that's out there, IPCC always have a chapter which is the summary for policymakers. But yeah, so it's a longer process, and then you don't know whether the government will listen too, right? That's another issues. But you can at least make people aware. Doesn't have to be scientists, media, consultant of the issue, what we are progressing, how they can help. I think that's part of the important part. I mean, people ask, how do you help climate change? It backs to your own personal daily activity. But I think, I mean, there's many young students and docents here. You know, climate change is a very exciting field. It changed so much, the knowledge changed so much. Like when I started in grad school, I started with a hypothesis that was so in that time. 3 years later, the hypothesis was not even valid, you know. So things change so quickly. It's that kind of field that if you in it, you really have contribution, you know. It's fast, it's so fast. So whatever you can contribute, I think it's very exciting. Yeah, thank you. So if any more people want to be climate scientists, yes.
Okay, we have another online question from Praditya Avianto. Hi Praditya. Data is the key word. So what do you think about our data library now? Because to collect a good data need a good budget. In this case, is a big problem.
Yeah, funding is one thing, but time is also two things, right? You can have big funding without time. But no, we're talking about good budget. So I think one thing about scientists, we also collaborate. So for example, in paleoclimate, let's say I study one area, but only one area. So what does it mean for the whole world? So what we do is actually we have a portal just for paleoclimate. We actually have an online. It's organized under NOAA, where let's say when I submit my paper, it gets accepted. The data is put in that portal. So anyone, educators can download this data. So that's our way to put together our data, and usually we also try to have a synthesis of all this data. So there is place we can put the data, and there's place where people can play around the data. So the data library is not just in Indonesia, I think, because it's also too small, but it has to be. That's why the website is like for all over the globe. Yeah. Did I answer the question to collect the data? Yeah, you need good budget for sure. Well, if I talk about budget, of course, Indonesia needs more research budget, but also need more human resource. We need more younger students get into earth science. I don't know why. I was actually very disappointed when I was in high school. We had this big El Nino, right? I mean, it was so devastated. Came at the wrong time. It was 97 when we had economic crisis. I mean, I was in this good high school, but I've never heard of El Nino. Like, how silly is that? You know, they make us study so hard with physics formulas and stuff, but not realizing what is really happening. So the first time I heard El Nino, I don't know if you're like at same age as me. There was a McDonald's commercial. Was it like the DJ from MTV, Aditya something? I still remember he was on the McDonald's advertisement. He had this umbrella and said El Nino, El Nino. That was the first time I heard of El Nino. It should have been in the textbook. So.
I see. So speaking about data, I would like you to share your experience about how you collect the data from the ocean. How difficult is it?
Yeah, that's a fun part of being scientist. You kind of have this different personality. So here, I'm like dressing up, but then with my pink shoes too. But in the field, it's like you have to be bolang, maksudnya bocah petualangan. So when we go to the field, because we want to get places as far as possible for any of you, human. So because we want to have a place where the corals will be recording climate, not pollution, not other things. So places like Natuna, and this year we're going to like Maluku part. So further places. So then you have to fly one place, second place, and then you in Natuna or even Takabonerate. I think we took the boat for 7 hours. So and then you have to be prepared. So when we in the field, drilling corals takes a lot of air. So the fuel to drill was actually compressed air, like the one that we breathe when we dive. So when we go to field, we have 25 tanks with compressors in our fisherman boat. And then we just work for 2 weeks, and every day we would dive only twice. But each dive, we will be in the water for 2.5 hours. So I feel bad for people waiting for us on the boat, because I mean, we were so focusing, working, diving for 2.5 hours. They can eat, they can do whatever on the boat, and then we will just go up on the surface after 2.5 hours. Then we have lunch, and then coffee, and then we go back working for another 2.5 hours. And after 14 days, we go home all unrecognizable, basically.
Big appreciate to all our oceanographer here, because it's a really big thing for all our friends from Research Center for Oceanography. It's really different because I am a social scientist. How we collect data, we only go to our informant and doing FGD and etc. But they leave their family back at their home for the Indonesia. Can you imagine that? This is really big thing for me, in my opinion. So, do you still have any question? Okay, madam.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. Your presentation very interesting, yeah. So maybe after this session, I would like to discuss with you personally, yeah. But for my my thinking, how we control our data, because when you collect the data and you have a portal, and if not wrong, the portal under the NOAA, and I know NOAA that from United States. So how we control for the security data, because data very important, data very expensive, need lot of budget for collect the data. But sometimes we don't care about the data, quote to quote, don't care about the data. So when we have collect the data, we, for my understanding, we have control our data. If we have lot of data, that the big data, from that we can analyze and can make decision for government. That's, I think that very, very important. So even though for this time we have to collaborate with all the countries, something like that. But more important, most important for us to be careful to control our data, to make security for our data. Maybe like me, because I'm not what's mean. Sometimes I'm very free, share information, data, etc. But if someone have knowledge, high knowledge about to compile the data, that can be can be make the other. So I only would like to know how we control our data for the security. Data have the open source, but we cannot, all the data can open source. Thank you very much.
Okay, thank you for your questions. Yeah, data is knowledge, knowledge is power, right? So data has different classifications. There are particularly oceanographic data. They are sensitive, especially for Indonesia. It's a matter of national security, and we know what are those data. So for paleoclimate, it's a different characters. It doesn't. It's not a social security, but it's more like scientific proud, I would say. Like if we don't get the data out, we actually, that's not good for Indonesian scientists' reputations. So for my paleoclimate data, it has not, it won't affect national security. So actually, because it's funded by public money, and not just Indonesia, but all over the world, if you're funded by people's tax, you have to make the data available. So why is in NOAA? Just because they had the infrastructure there, but actually the data there was from many countries. At one point, when the U.S. had a shutdown, I think they had a shutdown of the NOAA website, and we were kind of annoyed. So it was just like, well, maybe NOAA shouldn't handle it. Now that Trump is in power, there's probably more power shutdown. We couldn't, like, people couldn't access the data of NOAA data. So maybe France should have take over. I don't know. But so far, it's because they have the infrastructures, and there's no issue in terms of security, and it's our responsibility to get it out there. It can be used for many purposes. Yeah, so for I know for like oceanographic data, even in RCO, we do classify it and there's also so there's a classified very restricted access, but also there are data that are timestamped. So this data is logged for, let's say, 5 years or 4 years, so until it gets published. Then after that, it has to be published. At least the information has to be out there. Even if the data is sensitive, if we use public money, then it has to be out there. You have to make for paleoclimate, which is no problem. I put the row, really like the time, the number, and so on, so people can replot my plot. Yeah, thank you.
Okay, another question. Okay, madam with the red hijab.
Thank you for the opportunity for me. Assalamualaikum warahmatullahi wabarakatuh. My name is Salma from Pajajaran University. I'm a student, and let's straight to the question. I would like to ask, can all the climate change footprint that you mentioned, like sea level rising, acidification, and rising temperature, makes economical biota that we consume accumulate dangerous pollutants like microplastics or heavy metals? Thank you.
Okay, thank you for your questions. So it's slightly different than the pollutions issue, because the pollution issues like microplastics, organics, and stuff, it has a bioaccumulations cycles to it, right? It get eaten by plankton, plankton eaten by fish, and so on, and then we eat the fish. In terms of ocean acidifications, I think it's more a food security issue in the long term, in terms of our ocean producers. So, for example, coral reef, seagrass, those are nurseries for fishes. This is the nursery, though we catch it in the open ocean, for example. But if those nurseries are being endangered by ocean acidification issues, the corals cannot be building its blocks as it used to be. That's the logical of thinking. But in terms of the acidity, does not bioaccumulated in our study. Although, for example, you can take places maybe like Kepulauan Seribu, for example, or any more polluted area. The pH in those areas are lower, not necessarily because of ocean acidifications, but because of pollutions. And then whatever pollutions in that water can be bioaccumulated, but it's another different story. Yeah. So the pH itself, it's an ocean parameters, it's not pollutants. Oh, there's a follow-up question. Did I answer your question? Yeah, you can have the mic again.
I would like to comment your answer.
Yeah.
How about the rising temperature or another abiotic?
IPCC. IPCC is the Intergovernmental Panel on Climate Change. So they update
Can make biota consume more like pollutants,
For example?
I heard that the seminar from University of Indonesia last February, I think, about microplastic. The doctor said that biota can accumulate more microplastic when the sea temperature is rising, because more higher temperature, the plastics can be degraded into small pieces, and more plastic pieces in the ocean, the biota can accumulate more, and it related to the oxygen dissolved in our ocean. And I think that if the biota need more oxygen, the respiratory system will need more like breathing, right? And if the pollutants, small pollutants, I mean, concentrated in our ocean, and the biota need more oxygen, I think the biota can accumulate more the pollutants, the small pollutants like heavy metals.
All right, so it does sets for, so the main issue this will be more on the pollutions and how the surrounding, the ambient environment such as temperature and OA will enhance, right, the microplastic dangers part of it. Yes, I think it's possible, especially with the way microplastic issues, there's the degradation issue from bigger plastic to smaller plastics. So when you have warmer temperature, that will enhance the productions of microplastics. Yes, so but you need sort of you need the pollutant. So the temperature and acidic ocean itself is not, it's just an ambient parameters. There's no bioaccumulations aspects of it. But yes, when you add things like pollutions, microplastic, then it could enhance these pollutions issues. Yes. But yeah, in terms of so it's two different sort of reservoir or components. One is the ambient water temperature. The other is the chemical pollutants, right?
Yeah. Okay.
Yeah,
Thank you.
thanks.
Okay, with the right jacket. Okay.
Okay, thank you very much. This is one more maybe kind of question or just like this maybe. Actually, there is some institute in our country doing this kind of research. But I think one of the leader for the oceanography is LIPI. LIPI, right? One of the leader. I think one of the leader for the oceanography research.
Thank you.
I think is LIPI. So, but the problem is, for example, in my university, or maybe in almost university, we have a problem with the budget, and second one is also the facility. Yes, because maybe limited budget, but we have to share this budget for many kind of research, not only oceanography. So, in my opinion, it is possible maybe if we make kind of consortium or maybe something like collaboration between, for example, in my maybe like LIPI, BPPT, university, and maybe also some ministry, something like that. Because in my, it's very truly hard for me to get kind of data for oceanography data from Indonesia. Very hard for me. It's very difficult for me to find data about the oceanography in Indonesia. Even I'm working for the government, I'm working for university. I mean. For example, in the previous time, I also joined with the JPGU, Japan Geoscience Union. Between us, we can share many data, and this is very important to improve our research. Other other is AOGS, Asia Oceania Geoscience Union Society. I mean, also very easy for us to share so many data between us. For Indonesia, I think it's still very difficult to find this ocean, especially for oceanography data. It is possible or not? Because in university, the real condition is we very difficult to get budget, grant, something like that for oceanography. Just like what I did since maybe 1 year ago, I start to quit to research for the oceanography research because very limit budget. So I changed my research topic to the kind of material science because of this problem. So I just hope that maybe LIPI, one of the leader for this research, can make kind of consortium or something like that, so we can do this research together, especially in university. University has so many ideas, but we don't have enough facility and budget, something like that. Okay, thank you very much. Maybe this.
Thank you for sharing. Budgets is issues everywhere, even in developed countries. U.S. budgets is getting lower and lower, and sometimes you have other countries that have more budgets. But I mean, there's a certain amount of budget what we have to have, and facilities. In terms of facilities, talking about budget, I think, I know everywhere in Indonesia budget is tight. LIPI is also tight. But I don't know, I never worked in university in Indonesia, but the one that I observed in LIPI is we focus on roadmap. So if you have budget is every year, but then you have a 5 years plan as an institute. So your institute wants to accomplish this and this in 5 years, and within those 5 years you have to do this every year. So the way I see it, the implication is that we really have to stick with our roadmap. So even at limited budget, those programs needs to be working even at what level. So I think having multi-years commitment for the institutes really helps in this atmosphere of budget in Indonesia. But again, I don't know what's the university, but I've heard these stories a lot. In terms of facilities, even in LIPI, of course, we're not perfect in terms of facilities. We still have many lackings, to be honest. I even heard actually in some universities have equipments that we try to get, for example, at LIPI. Those stories I've heard. But even, when I came to Indonesia, even now, I don't really have facilities in Indonesia, but I use my connections abroad. So if you think that why do we have to have the same equipment in Indonesia, you can take it all over the world. You can make it bigger. Like if my collaborators have equipments there, why not use his equipment? And it would be nice for me to have one, but then there's also maintenance and whatnot. So using collaborations actually have really good. Not just in terms of using the instruments, I find it in terms of time, because in Indonesia we have so many non-scientific jobs, things to do. So if I try to make measurements in Jakarta, my heads are everywhere. As opposed to if I spend, like, for example, in Japan, 1 month just doing analysis, it's more effective, for example. And consortium, yes, there is now, with the endorsements of Bappenas, we have consortium Riset Samudra. So I think UNSUD, a while ago we have these signatures from Bappenas, LIPI, BPPT universities. I need to check if UNSUD was there. But the reason we have this consortium was exactly for the same issues. And this consortium is actually for Samudra, because most of the research in Indonesia is in the coastal, because it's so close, so easy. Then how about the deeper oceans? So then you need research vessel, for example. So the aim of this research consortium was actually also not only budget, to share facilities. So for example, at LIPI, when we do cruise, the cruise is not just full of LIPI scientists. We invite scientists from all over Indonesia, so that we can use our national research vessels for work. But then, you have to come up with proposal, and it have to make sense in terms of a bigger goal. For data, the government in Indonesia have mandates. So the National Ocean Data Center was actually mandated to BIG, Badan Informasi Geospasial. RCLIP is actually mandated as the National Data Center for Coastal Ecosystems. And that is growing. So I think the website is pusdata.oceanography.lipi.go.id. So do check it out, because in that website we have our data on the status of coral reef, because our mandate was actually coastal, right? So we focus on coral reef, lamun, seagrass, and mangrove. But because we have Barunajaya that takes oceanographic data, in one of the selections, you can actually to inform people what data we have. But we cannot sometimes put the raw data because of national security issues. But for Indonesia, everyone's welcome, right? I mean, so basically, if you're interested in those data, do contact us, and then we can collaborate on using those data. So right now, our job is to put the metadata, the information what's there, so people can use. Okay, thank you.
Okay, I don't think we don't have more time left for our first session. Give a big applause to Dr. Intan.